Okay, so we're going to take a little bit of a break here from the lecture and get you into problem number 1 on our handout this week. Problem number 1 says, given the following table of data, and it's a set of bowling scores, team bowling scores, we're going to organize a chart and show how we can obtain the mean, median, and standard deviation of the data. And you see that what we have right here is 14 bowling teams. Pin Pals, lol, what? Top Guns, Tiki Taverns, Yes and No, Blood, Sweat, and Beers, Rockin' Into the Night, Blondes 1, Right Hooks, Bo Brave, Southpaws, Moe's Mozart, Veni, Vidi, Vici, and Disco Stew. So what we're going to do is we're going to try and go through and we're going to organize this data. So let's start with our chart. You'll notice that in the chart right here I have 3 columns. The very first column says X. Each data point in this data set is a value of X. What our first job, anytime that we're going to deal with by hand, trying to go through, find things like the mean, the median, the mode, is that we have to organize our data. And the way that we always organize the data is to go from the smallest to the largest. So we're going to start with the smallest. And we look at our list right here, and we eyeball, and we look to see what is the smallest. And we see right over here, the team Mozart has a low score of 480. So that becomes our first entry. 480 right there. And what we're going to do is we're going to go down the list and one by one choose these values and order them from smallest to largest. It looks like the next largest one is Blondes 1 with a 510 team score. So take a moment right here, pause this video. You'll want to do this yourself. It's a very important exercise to make sure that you can organize this data. It usually takes a minute or two just to go through and organize that data, and then we'll compare our data points here. Okay, so I organized my data. Here it is. 480 was the lowest, 510, 525, 528, 530s, 2 of them, 534, 538, 540 and 545, 550, 560, 562, yeah, sure enough, 570 and 585. There it is, right? All right, so our next job is that we want to use this data to get our information. That is to get our mean, our median, and our mode. Now remember, here's what you're going to try and work this out. First, take a moment, add up all of these values. So add 480 plus 510 plus 562 plus 528 plus 530 and so on, and get the sum of those values right here. My little sum value right here to go. But put your sum right here. Okay. Then what you're going to do is that you're going to get your mean by taking the sum of all of those xi values, taking the sum of all our data points, and dividing them by n to get your mean. All right. Aside from getting your mean, you also will want to get your median. Pick the middle value and find your median, and then of course find your mode. And we'll compare notes, so take a moment and please do those things. Okay, let's see what information you got here. I got a sum of 7,527. Hopefully you did the same thing. The next thing I did was I took my 7,527 and divided it by 14. That gave me 537.6429 as my mean. We're going to use the number 537.64 for the mean right here. We're going to start rounding to the nearest hundredth. For our median, we added the 2 middle scores. We have an even number of scores, so we're going to take 534 and 538, and we're going to find our median by adding those and dividing by 2. So our median score was 536. And of course our mode here, the only score that occurred more than once, was 530. And so that is our mode. Okay, not too bad here. This is the measure. Now, of course, the next thing we want to do is we work on how do we get a standard deviation. All of these are relatively straightforward to find the mean, the median, and the mode, but finding a standard deviation is a little bit more involved. However, there's sort of a cookbook method of doing this one right here. I'm going to show you the recipe. The way it works is this. What you're going to start doing in the next line is that you're going to find the difference between each data point and the mean. So right here, for example, in our first entry, it says x minus x bar. So we're going to take the x value of 480, and we're going to subtract the mean. And go ahead and use the hundredth, if you will, 537.64. You're going to subtract those two, and you're going to get the number that goes right there. Same thing with the next term. We're just going to go right down the list, 510 minus our mean of 537.64. And we're just going to keep going down the list and getting each of these values. So take a few minutes and do that, and let's get your list of values. All right, let's compare. Here's my values. I got negative 57.64. I carried out my digits a bit right here because I used a little bit of a calculator. I just simply copied a calculator from my online internet as I did this. So I used my online calculator and I found all of these values right here. B64, negative 27.64, negative 12.64, negative 9.64, and so on. We get a bunch of negative values. You'll notice that in the middle we get one very small value. 538 is kind of close to the mean. As a matter of fact, 0.36 away. We're going to get 2.36, 7.36, 12.36, and so on down the list. And our next job is that we want to take each of these values in this list right here that we just developed, our sums, or our differences, and we want to square them and put the result next door right here. So you're going to square this first number, you're going to put it in this line, you're going to square the next number, put it over here, and you're going to keep on going down the list. Now what should happen is that when you square these numbers, be careful. The negatives go away. If you're entering this into a calculator, make sure you use parentheses yourselves or just skip using the negative at all. In this case, negative 57.64 squared, you would put parentheses around both the negative and the 57.64 before you square that, and make sure that your result right here should be a positive number. Alright, I'm going to take a few minutes and do that. That might just take you about a minute and a half. So I'll pause here. All right, let's see what you got. Here we go. I got my differences each time were squared. So you see I would get numbers like 3,322.70. It would be 0.70 and rounded up to the hundredth. 764.13, 159.84, 92.98, and so on down the list. So I've got a list of 14 numbers that are all squares. All right. Here's the way that I phrased my standard deviation formula right here. It looks a little bit different than what we presented in the slide, but essentially the way it works is this. Our sum of the difference between each of our x values minus the mean squared divided by n minus 1, so we take the sample size, divide by 1, subtract 1, and then divide, or take the square root of that division. Okay, it seems like a lot, and it is a lot if you're doing this by hand, but your next job here is to pause for a minute and go ahead and add up all of your numbers in column 3 right here. So get that sum of everything above in this column. All right, so let's take a moment. We'll pause. Okay, I got 8,565.21. It's pretty close. Those of you guys who are rounding, you're going to get a slightly different decimal, don't panic. That's okay. You should be pretty close if you're rounding it to the nearest hundredth. So let's see. Here's how it worked. What we said was that we were going to take that sum, put it in our numerator. Right? So we put that sum directly in our numerator, and we're going to divide by the number 13. So what we're going to do right here is we're going to take 8,565.21. You're going to divide by 13, and then you're going to take the square root of that result. So if you take a minute and you do that, you should be able to verify that the mean is 25, that the standard deviation is 25.67. All right, great job, guys. Hopefully that makes some sense. You can always rewind and take a look at what I did. But we'll continue our discussion about our measures of center and using all of this stuff in the next video.